Jai Hind to everyone. Namaste. So this is your Mahaveer sir. Today I am going to teach you one of the easiest chapter of the chemistry subject, that is acids, bases and salts. You might be worried, what are these acids, bases and salts? Or in case if you feel this is one of the toughest subject in your chemistry subject, then you are wrong. It is one of the easiest chapter. Nothing is there. Trust me. When Mahavir is here, why fear? In this chapter, it's one of the easiest chapter in the chemistry. Why? Because first let me tell you, in this chapter what we are going to study. Let us try to understand. We are going to study about what you mean by acids, what do you mean by bases, what do you mean by salts. Then, what are the chemical properties of acids and bases, and some types of salts which are there, their preparation and uses. Apart from that, we are going to discuss about what are indicators, what do you mean by universal indicator, pH scale, and what is the importance of pH in everyday life. That's all about the chapter. Nothing is there in chapter. But only thing is that when you see this video today, then you are not going to regret. That's my trust what I'm keeping on you guys. So please listen carefully, okay? And at the end of the chapter, if you have any doubts, please mention in the comment section. I am going to reply for each and every comment that you are posting in the comment section. So without wasting time, much of time, so let us try to understand this chapter. So first, let us try to understand what you mean by acids. So we all know that in so many food items, we know the acids are there, and so many other substances acids are there. Where acids are there? Inside our stomach, we know that HCl is there. That is the acid. We studied in the life process chapter. You guys have studied, yes or no? Then inside the soft drinks, we have carbonic acid. That also some sort of acids are there in the batteries also. Some sort of acids are there in the fruits or the vegetables like lemon or orange. So these are all the acids what we have known so far, and we feel that acids are danger. All acids are not danger. Some are edible that can be consumed by the human beings. Going forward, we will discuss all those things, and you will feel really so good about this chapter. But do not forget to practice once you see this video. First, let us try to understand what you mean by the acids. See, very simple concept is there that acids are the chemical substances that produce which sort of ions? They produce H plus ions, or so called protons. When they produce this H plus ions or protons, remember, in their aqueous state, or when they are placed in the water, then only they will produce H plus ions. Say for example, later we will discuss in detail, HCl, when we add the water inside the HCl, it will dissociate to produce H plus and Cl minus ions. So which ions they are dissociating in the water? They are dissociating the H plus ions only. That's the reason the definition itself say that it is a chemical substance which produce H plus ions in their aqueous state. No other chemical substances will produce H plus ions in their aqueous state apart from the acids. Another example you can take the example of H H2SO4. When it is combined with the water, it will produce 2H plus ions and SO4 2 minus ions. Again H plus. You take the example of the nitric acid HNO3. You take the example of any other acid. Definitely they are going to produce the H plus ion. This is one of the major thing you should remember about the acids. Let us try to understand the properties of the acids. See, acids are sour to taste. Acids are sour to taste. The sour is nothing but it is a kind of taste of the lemon or or the orange or the taste. No, that is nothing but the sour taste. And effect on the litmus paper. Effect on the litmus paper in the sense they turn blue litmus to red. We all know that two types of litmus paper are there, already studied in the previous year classes and all. One is blue litmus paper, another one is red litmus paper. Whenever the blue litmus paper, when they come in contact with the acid, they change their color from blue to red. If the red litmus paper, when they come in contact with the base, they change their color from red to blue. How to remember, sir? See, remember, blue to red in the acid. Red means danger, acid. If the litmus paper is changing from red to blue, blue, B, that is base. So you can remember in that way. So they are corrosive in nature. See the next point. They are corrosive in the nature means they corrode when they come in contact with the metal. What do you mean by corrode or corrosive? That means they destroy the properties of the metal when they are in contact with the acid. So example, hydrochloric acid, sulfuric acid and the vinegar, these are the some of the example. So hope it is clear for you, acids and their properties and the definition of the acid. Next, let us try to understand the bases. Like how in the acids we discuss that acids are the chemical substances, they produce H plus ions. Similarly, the bases are also the chemical substances, but they do not produce the H plus ions. In fact, they produce hydroxyl ions or OH minus ions. Let us take an example. NaOH, treated with the water, when treated with the water, they produce Na plus and OH minus ions, hydroxyl ions. We call it as hydroxyl. We take the n number of example of the any of the what any of the bases. Say for example, we take the magnesium hydroxide. Okay, again in the aqueous state they produce what? OH minus ion. That's the reason we are calling this chemical substance as what? As what? As the base. Apart from that, few more properties are there. Let us try to understand. Like acids, we discussed, no, they are so to taste, but bases are bitter. They are bitter to taste. The bases are present in so many other substances where day to day we use and all. Say for example, in the soaps and all, the base is present. It is present in the detergents. It is present in the cement. It is present in the toothpaste what we use for brushing and all. It is present in the laboratory and it is also present in the fertilizers like ammonia is also kind of base. So next property, this is very interesting. Like acids are corrosive in nature, we all know that, but bases feel slippery or soapy to touch. Means what? When you touch like this, it will not feel slippery or soapy and all. We need to touch, and when you rub between the fingers and all, you will feel slippery or soap like. That's the reason. That is also one of the property of the base where they are telling that it feels slippery or soapy to touch. Then next point is, as I mentioned already, that they turn red litmus to blue. Hope it is clear. Okay. So, example, sodium hydroxide, you can take magnesium hydroxide, calcium hydroxide, copper hydroxide, aluminum hydroxide. All the hydroxyl containing groups are all will be coming under the base itself. Okay, remember that. So, let us go to the next concept. Hope if they ask what are acids and bases or difference between acids and bases, aram se you can tell the property. Or sometimes they might give the one of the properties of the acids or bases and ask you to tell the nature of the substances. So based on the property, you can very easily can tell which is the acid and which is the base. So next one is indicators. So what are indicators? Hope you have heard this term well before. No? Well, while going on bike and all, no. So they'll show the left and right indicator, no, the light will start blinking. Okay, that is not the indicator what we are going to discuss. That is different indicator that in context with the what in context with the automobiles or motorbikes or cars and all. This indicator is very interesting. Why it is very interesting, you know? These there are some chemical substances. Okay, what they will do, you know? They change their color or smell when they come in contact with the other chemical substances. I repeat once again, those are the chemical substances where they change their color. They change their color or smell when they come in contact with the other chemical substances, then only these particular chemical substances are called as an what? As an, yes, you are right, as an indicator. Say for example, we get so many examples are there, like general example which already discussed in the previous chapter, that is in biology, that is life process chapter. You might be heard about the iodine. Iodine, when it comes in contact with the starch, its color will become blue, black or violet in color. That's the reason iodine is an indicator. But here we are going to discuss about those indicators specially where they change their color or smell when they come in contact with the acids or bases. Those indicators we are trying to understand in today's session. Now see here, types of definition is given, you can see here. Indicators are the chemical substances which change their smell or color when they come in contact with the other chemical substances like acids or bases. Such chemical substances we call them as what? We call them as indicators. Very simple. So there are some natural indicators which are naturally found in the nature, and there are some synthetic indicators which are made by the man or in the laboratory by using the chemicals and all. So let us understand the natural indicators. Where they are found? They are found in the plants. Plants like what? Plants like litmus, red cabbage, hydrangea flowers, leaves extract, and turmeric. Okay. Similarly, how they change the color and all, we'll study very in the next slide. So till then, just hold on. Synthetic indicators are those indicators which are made by the man. We prepare those indicators. Best two examples are there, and those names are also a little bit very nice or unique names they are given. I personally like or love those names. One is, see, how do you pronounce this? This is very simple. Phenolphthalein. Can you say it? Yes, you can try. Phenolphthalein is one indicator, and this is very simple. Methyl orange, which is orange in color. How they change their color when it comes in contact with acid and bases, we are going to discuss. Another type of indicators are the olfacto. Okay, you can remember that name of that, meaning of that name. All factory indicators are those indicators. They will not change their colors, but in fact they will change their smell when they come in contact with the other chemical substances. Such indicators we call them as olfactory indicators. Example: onion extract. Onion extract means what? Means they will extract the onion juice from that. Vanilla extract means they extract the vanilla juice. So that's what the term means, onion extract or vanilla extract. And the clove oil. Okay. So these are the three examples for the olfactory indicators. So now let us try to understand how they change their color when they come in contact with the acids and bases. Everything is there in the one slide also. So whenever I'm moving this side, make sure that you take the screenshot so that it will be very useful for you guys to refer it post watching the videos and all. One more thing what I like to suggest is, whenever you are reading the subject, please try to understand. Do not buy at anything. Science is not meant for buying the things and all. That is my personal suggestion. I keep on telling to my students, do not buy at anything. If you're not understanding, keep on asking to the teacher until and unless you understand. And the same day itself you need to practice those things by writing. Then only you can remember for longer period of time. Chemistry subject is very easy to understand, but very easy to forget until unless you what? Write and practice without seeing. That is the best formula for the scoring out in any of the subjects, especially like science and all. Okay, fine. So let us not waste too much of time in giving gyan and all. Okay. We'll tell it again when and where the time comes. Okay, now see, these are the indicators, natural indicators. Litmus is there, red cabbage, flower of hydrangea, and turmeric. Second and third, don't need to worry, but at least you remember litmus and turmeric. Most of the questions will come on this. Then here, phenolphthalein, methyl orange. Here, all these three you need to remember. Red cabbage. First one is litmus. Already we discussed about the litmus, that when it comes in contact with the acidic solution, its color changes into what? Its color changes into red color. And when it comes in contact with the base, its color changes to what? Its color changes to blue in color. This already we have discussed. Red cabbage leaf extract, acidic medium, it will change color to red. basic, it will become green in color. Flower of hydrangea, blue in acid medium, pink in basic solution. This is very important. Turmeric powder. Okay, you might be knowing. Yes. So there is no effect on the acidic solution. When it comes in contact with acid, there is no change in color. But when it's come in contact with the base, definitely its color changes to red in color. Red in color. That's the reason, no. Our mothers and all, what they will do, they will, whenever we have the turmeric, kind of stains on her clothes and all, she will not use the soap because she knows better than us. Why? Because experiential learning, we will tell. Experiential learning, she has done it and she has seen that when she uses soap, the turmeric stain is changing its color from what? Yellow to red. So that's the reason they will not wash with the soap whenever we have the turmeric stains on our clothes and all. Next one is synthetic indicators. These are very simple. Phenolphthalein, remember when you see the phenolphthalein, no, it is colorless actually. It is colorless. Watercolor. Color means watercolor. Once it come in contact with the acid, it remains colorless only. But once it come in contact with the base, no, it will change its color to what? It changes color to pink. P for phenolphthalein, B for base, P for pink in color. You need to remember. Next one, methyl orange, it will be orange color only. Okay. So one more thing I forgot to tell that, remember that after this video, no, within 4 or 5 days, I am going to do all the activities and in lab, and I am going to upload into my channel. So please do subscribe my channel, hit the notification button within 5 days. Remember, I am going to upload the video of all the activities of first and second chapter which are there for your midterm exam. All the activities. Okay, I'm going to do in the lab. So keep that in mind. Okay, do not forget to watch that because very rare we can find the videos in the YouTube where they did all these experiments in the labs and all. But I am doing that only for whom? For you guys only. Okay, anything for you guys. Okay, when Mavi is here, why to? Yes, you are right. Why to? Fear, not fever. Huh? Fear. Mahavir sir will not make you to fever and all. Fear. हाँ. कभी कभी गलती हो जाता है, गलती सुधारना चाहिए. ये तो मेरा पहला यूट्यूब वीडियो है, वो भी कैमरा देख के I should tell for you guys. Next one, olfactory indicators. That is onion extract. They'll not put onion and acid together and all. Onion extract. This onion से जूस निकाल के उसमें क्या करते हैं, एसिड और बेस डाल के देखते हैं कि स्मेल चेंज होता है कि नहीं. But what happens, no? See, all this onion, vanilla essence or extract, clove oil, all this, they retain the smell. Same smell will be there when they come in contact with the acids and all. But with the base, the smell will diminish or the smell will change. So you need to remember that. So mostly they'll come up the question with in exams, board exams, that litmus, turmeric, phenolphthalein and methyl orange and all for 1 mark and they'll ask. So hope it is clear, very simple. When I upload the video of the lab activities of this chapter, so you can go through, you will understand very clearly. Science is not a subject to visualize the things. It might be like this, it might be like this. No, you need to see and learn the things. This is not sufficient, but yes, activity based questions will come in exam, right? Around altogether physics, chemistry, biology together around 15 to 16 marks. If you want to score, that means in your respective schools, they need to, what they should do? They should do all the experiments or all the activities in lab and they should show you. Then only we can learn in a better manner. So next one is the chemical properties of the acids. Then later we will discuss chemical properties of bases also. They are very, very simple, nothing complicated and all. So let us go across without wasting the time. That is, the first one activity is reaction of the acid with the metal. So whenever the acid will react with the metal, no, they will form their respective salt and water. They are telling it. They will form their what? Respective salt and hydrogen gas is liberated. I'm sorry, I told water. Okay. So when the acid will react with the metal, they form the respective salt and which gas is liberated? Hydrogen gas is liberated. This is one of the very important diagram. How many times they ask in board exam, there is no count and all. And it's very simple diagram. Let us try to understand what this activity is all about. Okay. Just do not focus on this equation, just focus on this equation. Let us try to understand this activity step by step, and it is very very simple. Already we have done this in lab, and definitely I am going to upload the same for you guys. See, there is a test tube, stand is there, test tube is there. So they attach the cork, and this is a delivery tube, and this is a container containing the soap solution. Okay. Now see here, what happens over here is, inside the test tube, what they have taken the HCl. What they have taken? HCl, or we can take the sulfuric acid, H2SO4, where inside this test tube. This is a strong acid, we all know that. Then they will take off the cork, cork will be not there. Then they put what? They put the zinc granules. Zinc is a metal, it will be silver metal, silver color metal. So when they put that zinc metal into the acid, no, they react with each other. Zinc will react with the H2SO4, and it will form what? Zinc sulfate plus hydrogen gas is liberated. And remember, this is a type of displacement reaction which you studied in the first chapter, chemical reactions and equations. Zinc is more reactive than the hydrogen. That's the reason zinc is able to displace the hydrogen from its salt solution. Okay. So, during this reaction, what happened? You can see the small bubbles over here. That bubbles are because of what? That is because of the liberation of the hydrogen gas. Then what will happen? That hydrogen gas will not escape into the atmosphere. That's the reason they have put the cork here. Rubber cork is there. You can see the brown color, and that gas is collected into the delivery tube, and that delivery tube is dipped inside the soap solution, so that the hydrogen gas will produce the soap bubbles. And that bubbles, no, when they are rising up, when you hold the fire, okay, or the candle near that, that particular bubbles will give pop sound. Pop, pop, top, whatever sound it is, pop sound. Why it is so? Because hydrogen is a fuel, we all know that. It is highly combustible. Now, small molecule of hydrogen gas is carried by the soap bubbles. Definitely, it will make some sound, some sort of sound. That sound is nothing but the pop sound. How exactly that sound will come? Definitely, we will come to know within 5 days, which where I am going to upload that video for you guys. Okay, so this is what the experiment is all about. The same explanation about the experiment or the activity is given over here. Let us have a look on that. Take about 5 ml of the dilute sulfuric acid in a test tube and add a few pieces of the granules of the zinc. After that, hydrogen gas bubbles formed on the surface of the zinc granules that will pass that will allow to pass this gas through the soap solution through the delivery tube, and which are filled with the hydrogen gas. So whatever the soap bubbles are forming, inside the soap bubbles, what are there? Hydrogen gas is there, which is carried by the test tube towards the soap solution. And when you hold the fire near that, it will give which sound? It will give pop sound. This will give pop sound. So remember, pop sound. Okay. How that pop sound will come? We'll see that very soon. That's the reason I'm telling. Please subscribe. Please hit the like button. Please comment any feedback is there if I'm going too fast, or do I need to any other language. Okay, I'm not that good at Hindi, but I'll try to use little bit and all. Fine. This is one of the very very interesting and most oftenly questions are asked based on this concept. Trust me. Mostly they'll come up the question, applied questions they'll take. It's not actually applied question that's a direct questions only, but here and there little bit they'll twist and they'll ask, but it's very simple concept. So please do focus. If your mind is a little bit diverting here and there, you can pause and you can see, not a problem. But when you're seeing, no, you need to see, no need to worry by seeing all those reactions and all. They're very simple. When Mahaveer is here, then no need to fear. Fine, fear. Okay, let us try. Now, see, remember one thing. Let me write it over here so that it will be very easy for you guys to understand. Okay, what is that? That is, acids and bases, they react to form. They react to form what? They react to form respect to salt and water. We all know that acids and acids will not react. bases and bases will not react. Acids will react with the base or base will react with the acid. One thing what you can remember, you can write it down in your rough book if you want. See, remember metallic oxides, metal carbonates and metal bicarbonates. See, metallic oxides, metal carbonate, metal bicarbonate, all these three chemical substances are basic in nature. Take the screenshot if you want. Okay, they are basic in nature. And remember, which are going to discuss later, that is non-metallic oxides are metallic oxide, metal carbonate, metal bicarbonate are basic in nature. Then non-metallic oxides are what? You are right, 100% right. They are acidic in nature. They are acidic in nature. So simple, very simple. But you should know which are metals and non-metals. Don't ask me, sir, please teach what are metals, what are non-metals. You are telling what are carbonates and all. You are already studied in the class 9 whole year. If you don't know, then just please go back. I cannot go back and deep and tell what are metals, what are non-metals and all. It will be very horrible. Then this video will go for 5-6 hours. Now time is what? Around 11 o'clock, 11 p.m. Not 11 a.m. and all. Okay, fine. Let's not waste too much of time. So let us try to understand the further things. Fine. Now see here. When metal carbonates and bicarbonates, see metal carbonates means CO3, metal and carbonate compound will be there. Metal bicarbonate means HCO3. Or we can call metal bicarbonates or we can call them as metal hydrogen carbonates. Both are same. Both are same only. Metal carbonates and metal bicarbonates we can call bicarbonates or we can call it as hydrogen carbonate also. Both are same. Reacts with the acids to produce salt and water and carbon dioxide. Here there is one interesting thing. See, now this is the acid HCl. Now metal carbonate and metal bicarbonate when they are reacting with the acid means these two are what? These two are basic in nature. That's the reason they are able to react with the acid. You have to understand that. Okay. But what we know that acids and bases will react to form the respective salt and water. That's what we know. But remember, very important thing: whenever there is a carbonate, whenever there is a carbonate molecule or the compound in the reactant side, then then listen, then there will be release of the carbon dioxide on the product side. Any sort of, if you come across any type of chemical reaction and they are asking which gas is liberated, and if there is a in the reactant side, that is there is a carbonate compound, close your eyes and write that is a carbon dioxide gas. You will not close your eyes and you will write. Means without thinking you can go ahead and write that okay, the gas which is released during this reaction is the carbon dioxide and all. But when they ask when the metals will react with the acid, which gas is liberated, how do you test for that? Hydrogen gas pops on, already we have discussed. Now here there is a little bit twist, like in the movies there will be climax and all. No? One climax is going to come. That is very interesting and yet it is very very simple. I know, while making PPT, this arrow marks are gone little bit higher. Okay, please do adjust. Okay, I don't know why it happened. So I know you guys are not that much this thing, like you can't understand, you can understand. Like now see here, now there when the metals were reacting with the acids, the gas liberated the hydrogen. How do you come to know that gas liberated hydrogen or not? By holding the fire near the soap bubbles, then the pop sound came, then we said that yes, this gas is hydrogen gas. Now the gas liberated is carbon dioxide. Now how will come to know? We can't see and tell, no, okay, this is the carbon dioxide and this is the hydrogen. There is no color for both the gases and all. Or we cannot smell, this is the hydrogen gas, this is the carbon dioxide gas. That also we can't do. We all know that. Okay. So the best way to test the gas liberated is the carbon dioxide or not. Whenever in that reaction, if the gas is released, that gas need to be collected and it should be passed into the lime water. Where we should pass? We should pass into the lime water. CaOH twice. Calcium hydroxide is commonly called as what? Commonly called as lime water. When we pass, no, the carbon dioxide into lime water, then it will form the white precipitate of calcium carbonate. What will form? It will form white precipitate, we can tell, or there is a appearance of milkiness in that solution, appearance of milky milkiness, or there is a formation of insoluble particles of the calcium carbonate. See, lime water is also kind of little bit colorless only, and the carbon dioxide gas is passed. Then later what happened? You can see the thick insoluble particles of calcium, formation of the calcium carbonate, and along with that water will be formed. You can see it very clearly. Now I told no, there is a climax. Now you see what is the climax, will understand. In the movies and all, climax will be there, no? Like that there is one climax. Now here we have taken the test tube and we have taken the solution of lime water, then we pass the carbon dioxide. Now there is a white precipitate is formed in this particular test tube, but on passing excess amount of the on passing excess amount of carbon dioxide to the solution where already the white precipitate is formed, that carbon dioxide again it will react with the calcium carbonate and water. Now see, this is formed. How it is formed? When the carbon dioxide is passed to the lime water, the calcium carbonate is formed. Then we are telling that yes, the gas released in this reaction is carbon dioxide. After formation of calcium carbonate also, if we keep on passing calcium, excess amount of carbon dioxide, this will again react with the calcium carbonate and water. It will form calcium hydrogen carbonate or calcium bicarbonate. This calcium bicarbonate is soluble in water. That means it will get dissolved in the water. That means the white precipitate will disappear. That means milkiness will fades away. It will diminish. Why? Because there is a formation of soluble particle, so-called calcium hydrogen carbonate. Before there was the insoluble particle of calcium carbonate. Again, after formation of calcium carbonate, we kept on passing the carbon dioxide. That carbon dioxide again it reacted to the with the calcium carbonate and it has formed the calcium hydrogen carbonate. This is the climax. 1 mark question they'll come up with. Are understanding? Am I going too fast? If you feel I'm going too fast, you can just slow down the speed. Okay, fine. So that's what they're telling us here. Metal carbonates or metal bicarbonates. There's a general equation of them. Metal carbonates and metal bicarbonates. They react with the acid to form the respective salt and water and carbon dioxide. It's very, very simple. Nothing to worry. Okay, so it is. This is given in your textbook in the orange color box. Okay, this thing. So you can read it out. Don't skip anything. Whenever you are decided to study something, no, show some interest. If you're not understanding any particular sentence or any line or any single word, please do ask. Have a habit of asking the question. The more you ask question, the more you learn, the more you remember. Lesser you ask, then definitely we'll tend to forget so many things, and that's how you score less marks in exams and all. All are very, very simple concept. Okay. Now next one is the same experiment they are given here. Let me explain about these activities and all. Okay, the same what we discussed just now. No, how do metal carbonates or metal bicarbonates react with the acid? This is given in the textbook also. See, there is a thistle funnel over here. You can say thistle funnel, and there is a test tube. Inside test tube, first we will take the what we will take. First we will take the dilute sulfur HCl, that is the hydrochloric acid we have taken inside test tube. Then we should put the rubber cork. Inside that we should put one delivery tube. This is delivery tube and one thistle funnel. What is this? Thistle funnel. This is meant to add the sodium carbonate or we can add the HCl also. Or first you take here inside what you take the sodium carbonate or sodium bicarbonate, then put the rubber cork along with the inside the thistle funnel. What we should add? We should put the HCl. Then it will liberate the gas. Which gas it will liberate? Carbon dioxide. That is collected with the delivery tube and it is passed into the calcium hydroxide or so called lime water. This is what we just now discussed earlier, and this is the setup for that particular experiment. We'll do this also. Okay, fine. So next one is how do acids and bases react to each other. So Let us try to understand that whenever we have acidity problem, so what we'll do, our mother will give some soda. Along with that, she will add some lemon juice inside that. Okay. Even though inside the lemon citrus acid is there, but more components of the alkaline are present in the citrus. That's the reason they add. Because already we have acidity. Why the hell our mothers will give the acid again then? So that it should burn more and all. Understand what I'm trying to tell? See, baking soda she will give, which is used for cooking and all. That is a base. That is sodium carbonate. Along with that, we are squeezing the lemon. You go and ask, no, nobody knows this because more than acidic components, the alkaline components are more in number. So that's how we take that base into our stomach. That time the acidic level will come down or it will neutralize the acidity in our stomach. That's the reason we are calling baking soda as an anti-acid. We'll discuss that further in detail and all. Now, what do you mean by neutralization reaction? Neutral, neutralization reaction means what? क्या है ये neutralization reaction? उसका मतलब क्या है? उसका मकसद क्या है? कुछ नहीं मकसद है, उसका मकसद है to form just salt and water. Whenever the acid will react with the base or whenever the base will react with the acid, it will form their corresponding salt and water. Corresponding salt means their respective salt and water it will form. Best example we can take here. This is the acid HCl and NaOH is the base, that is sodium hydroxide and hydrochloric acid they have taken. So it is forming what? Sodium chloride and water. Sodium chloride and water it is forming. You take the another example. Take the example of H2SO4, that is sulfuric acid plus sodium chloride. Then it will form the respective salt, so called Na2SO4 and plus H2O, again respective salt and water or corresponding salt and water. Such type of reaction where the acids and bases react with each other to form the respective salt and water, we call those reactions as neutralization reaction. And it is having so many applications in our day-to-day life. Okay, hope it is clear. So next one, reaction of the metallic oxides with the acids. Reaction of what? Metallic oxide with the acids. So already I told you. What I told you? Recall. I told you to take this screenshot. You remember metallic oxides, metal carbonates, yes, metal bicarbonates. All three are basic in nature. Basic in nature. That means definitely the metal oxides can react with the acid. They can form the respective salt and water. Now copper oxide, name the element X when heated, black color compound. Do you remember first chapter? Yes, this copper oxide is black color compound. When treated with the acid, it will form the green color corresponding salt, so copper, chloride and water, which is a byproduct. So see here, again same. Metallic oxide react with the acids gives corresponding salt and water. This reaction is similar to what? Neutralization reaction. Similarly, this example, you can take the example of one more example we'll take. Now, what is there in that? So many examples are there. Don't only restrict to only one example which is given in the textbook. You cannot learn. Try your own example. See whether their respective salt and water are coming or not. So now don't ask me, sir, how CuCl2 came, why not CuCl3 and all, because of the balance is Cu2 plus Cl minus, that already you studied in the first chapter or the last year and all. Let us take one more example we'll take. Yes, okay. MgO, magnesium oxide, you can take HCl, okay. This is a metal oxide, this is acid, hydrochloric acid, it will form what? Magnesium chloride plus H2O, Mg2 plus Cl minus, so MgCl2. So general equation or the equation for this reaction, metal oxide plus acid, it will give respective salt and water. Okay, so I need to drink little bit of, okay, little bit water. I'll come back to you. Till then you can take this.